What you already have learned and may recall now is probably about graphing a second-degree function, their shape known as parabola. And now that you have acquired a knowledge of more than just x and y intercepts, you can put ideas of intercepts, asymptotes, symmetry, domain and range, continuity, max and min points, differentiability, concavity, and inflection points together and graph any function more confidently and perhaps efficiently. During this lesson, you will learn to graph any function, and it is super easy. Imagine that you are given f of x as 3x to the power of 4 plus 7x cubed. The first step for any function you want to graph is to find x-intercepts. You can do it by setting y as 0, factor and find values for x. So let's do this. We go ahead and say, okay, y equals 0. So it means that 3x to the power of 4 plus 7x to the power of 3 equals 0. So I'll go ahead and factor it out, and I have x as 0 and negative 7 over 3. So what are these? X-intercepts. The points on the x-axis through which your function passes, and f of these points are going to be 0. This is pretty straightforward idea. You should know it. The next step is finding y-intercept. It is a piece of cake. This time set x equals 0 and solve for y. Y would be 0 here, okay? So you can see the x and y intercepts on this picture. So we have the first x-intercept at this point, that is negative 7 over 3. The other x-intercept is 0, and the y-intercept is also 0. So the points that our function passes through on x and y axis. So our original function was f of x equals 3x to the power of 4 plus 7x cubed. So the next step would be writing the first derivative of y prime, finding its zeros, writing second derivative of y double prime, and writing its zeros as well. So first derivative would be 12x cubed plus 21x squared. Its zero is going to be x equals 0 and x equals negative 7 over 4. Second derivative would be 36x squared plus 42x. Its zero is going to be 0 and negative 7 over 6. So except for the x and y intercepts, we have some numbers, okay, that are zeros of first derivative and zeros of second derivative. So zeros of first derivative, we know that they are candidates for minimum and maximum points, and zeros of second derivatives are going to be our inflection points. Okay, so we create a table here, and we start by saying, okay, from negative infinity to negative 7 over 4, we choose any number. We can choose any number. And if we choose, for example, negative 2, it's between negative infinity and negative 7 over 4, okay? Our first derivative formula, we use that negative 2 instead of x and put it in the first derivative formula. So the value of first derivative would be negative. If we put that in second derivative formula, the value would be positive. So at x equals negative 7 over 4, f of x is negative 9.38. First derivative would be 0, and the second derivative would be a positive number. If we choose any x between negative 7 over 4 and negative 7 over 6, our first derivative would be a positive number, the second derivative also positive number. At x equals negative 7 over 6, f of x is negative 5.56. and first derivative is positive, second derivative is going to be 0. If we choose any x between negative 7 over 6 and 0, let's say negative 1/2, y prime would be positive and y double prime would be negative. At x equals 0, f of x is 0, first derivative is 0, and second derivative is 0 as well. And if we choose any x bigger than 0, first derivative and second derivative would be positive. So what is important here? So inferences are important. So we know that if first derivative is negative value, the function, the original function is decreasing. And since the second derivative is positive, so it means that it's concave up. At point x equals negative 7 over 4, first derivative is 0, so we know that we have candidates for minimum and maximum relative points. And since the second derivative is positive, we say, okay, it's going to be a relative minimum. In this area between negative 7 over 4 and negative 7 over 6, since the first derivative is positive, we know that the function is still increasing. Actually, it starts increasing. Sorry about that. And since the second derivative is positive, it's going to be going concave up. Because after the minimum point, okay, you can see that, okay, it starts going concave up. At x equals negative 7 over 6, f of negative 7 over 6 is negative 5.56. First derivative is a positive value, so the function is increasing, and the second derivative is 0, so it means that we have an inflection point. If we choose any x between negative 7 and negative 7 over 6 and 0, first derivative is positive, the function is increasing, second derivative is negative, it means that it's actually concave down. At x equals 0, first derivative is 0, so we have candidate for minimum or maximum relative point. But since the second derivative is 0, the test fails, and we're going to have inflection point. And if we choose x bigger than 0, first derivative is positive. So we know that it's increasing, the original function is increasing, and it's concave up since the second derivative is positive. So I can show it here on the graph. So if I want to draw this, so I start from negative infinity, and I go through the first x-intercepts at negative 7 over 3 here, and go down, down, down. It's decreasing until the point x equals negative, and the f of negative 7 over 4 is actually here, negative 9.38, okay? And we have a relative minimum here, we know, okay? And then graph starts increasing, and it's actually concave up, still concave up until the point negative 7 over 6, and its corresponding y is negative 5.56 around here. So from here, although the graph is still increasing, but we have an inflection point here, because at this point we have the second derivative as 0, and we can see that although it's increasing, okay, it's actually going concave down up until the point negative 7 I'm sorry, up until point 0, okay? up until point 0, it's actually increasing, concave down. And at 0, we have another inflection point, and then it goes up, concave up, and it's increasing.